Problem gives you this information that I've listed here in this order. The first number they give you is omega naught, and it's in RPMs. Now, RPMs is not a good unit. You need to switch that to radians per second. Hold on. Radians per second. They tell you basically that it's going to stop, so that means omega equals 0. They give you the torque, and they say the units are meters times newtons. That's the same as newtons times meters, so that unit is fine. They tell you the mass is 4.8 kilograms. That's the right unit. They tell you it's a cylinder, which means, you can look up in the table, that its moment of inertia is mr squared. They tell you the radius, and meters is the right units. So the first thing they ask you is to find how far it turns, which is theta. And that means that we're going to take theta naught equal to 0. And then the second thing they ask you for is the time. Now we can calculate these in either order. So because we start with the torque, the way to find the angular acceleration is from torque equals I alpha. So because we have the torque and we need alpha to find this stuff, we need to use the moment of inertia. So the torque is going to be equal to the moment of inertia, mr squared, times alpha. So that means that alpha, the angular acceleration, is just going to be that torque that you know, divided by m, which is 4.8, times r squared, that 0.017 thing, right? So now you have alpha. Once you have alpha, you could calculate these in either order. Now, because I have omega and omega naught and alpha, I immediately think of omega equals omega naught plus alpha t. And since I have omega and omega naught and alpha, it's easy to find the time. The time is going to be omega minus omega naught divided by alpha. Now it might bother you that when you did this, alpha didn't come out negative, but you can just change it to being negative here to make sure the time comes out positive. So that way you can calculate B first, you get the right answer, and then I would go to this equation, theta equals theta naught plus omega naught t plus 1/2 alpha t squared. Using the time I just calculated, and making sure I make alpha negative, using the omega naught from the beginning, and then theta naught we know is 0, and I can easily calculate theta.